Welcome back, everyone. I have written all the required points on the chapter 3 for this module 1. So here we'll be fastly going through all the points and all the topics under chapter 3. So I thought there are only 3 chapters in the first module, but we actually have 4 modules, and it's not that lengthy or any that big thing to complete. So here you have this, what is BDA, what is big data analytics. So you have 1, 2, 3, 6 points over here. Okay, let me just explain you all the 6 points quickly. The first is technology enabled analytics. In the sense, what they say is nothing but you have these latest technologies, right? All those things like Tableau, Power BI, etc. You have to use all those tools to analyze the data. So in the latest current technology, you have to use such tools. Then move code to data. Move code to data is nothing but see, suppose you have huge enormous amount of data. Now moving this data to the these tools and technologies, like nothing but code. So it will take a lot of what to say. You have to travel or move very huge amounts of data, and that's very time consuming. It will take many days and all. So why not we simply bring this code to the data, and it will do all the analysis over there. You understood, right? So instead of, see, this is the Hadoop or any system or any latest VDA tool, and this is huge data. Instead of taking all this data and coming, it is very time consuming and not that efficient or optimal. This whole thing, let it be there. I'll just move the tool here and analyze everything and give to me. Richer business insights. So it's nothing but you learn patterns about customer, about your partners or any other people related to business, so that you understand them better. And next time when you introduce any product to the market, you will be able to understand what to give, like favorite brand with our favorite color. Real time better decisions. So streaming data, so whatever, like fraud detections, or someone tries to log into your account, the way Google sends you what to say, email or something like that, like someone is trying to access your account like that. It's all about that. And like fraud detection, it has to react very quickly, so that is real time better decisions. Competitive advantage. So now, it's all about time. So if you know about something, who understands the data faster. So all this data is there. If you understand the data faster, then you will be the one bringing good insights for the business and all, and you will be working more good. So you can design better products with fast understanding the data. So learn the data fastly and design better. Tight collaboration, nothing but IT sectors, data based scientists and all. They all are how related together. Like IT builds platforms, data scientists build models, business users ask the right questions and act on the results. The tight collaboration, just understand how these three things are related to each other. Classification of analytics. So you have your first view and second view. Basically, previously and the current type, how it is. In the first view, you have to talk about these 4 things: basics, operational. You have to write analytics over here. I did not write analytics. Basic analytics, operational analytics, advanced analytics, and monetized analytics. Basic operation analytics, nothing but making these charts, flow charts, graphs and all. Small analytics and all, comparing the data and Excel sheets and all those analysis and all. Yeah, all can we say that a human by himself or a user can do it. It's just small. Operational analytics, nothing but when it comes to business related things. So it's automatically called operational analytics, like all those dealing with the large data and all. Advanced analytics, nothing but using predictive model reasoning, predicting the future and all. So it's all about those type of analytics where use multiple data and predict the stocks and all future predictions. The way you can see, like what will be the growth after this many years, all predict analysis. Advanced, it comes under advanced analytics. Monitor is nothing but this analytics, nothing but analyze the data to get revenue from it. So you're analyzing the complete market data. The best example is YouTube analytics, where you all manage all the data and everything and gives us the revenue. Talking about second view, you have 1.2 analytics, 2.2, 3.2. So in 1.2 is nothing but descriptive analytics. There is only descriptive analytics. When you talk about 2.2, it's descriptive plus predictive. This plus above one, previous one and predictive. 3.2, all the three: descriptive, predictive, and prescriptive analytics. So basically, in 1 point, you talk about what happened and why did it happen. In predictive, what will happen? Predictive, right? You have to talk about future. What will happen? Why will it happen? In prescriptive, it's like what will happen and what we will do, what we can do for that, either to stop from happening or to improve it or something like that. You can see the notes to understand better. Then you have why do we need big data analytics? Okay, so why big data analytics is important. You already know why do we need it. It is important. So there are 4 points. One is reactive business information, reactive big data. So under the reactive business information (BI), we talk about all those traditional database systems in which you use the business information, doing all the analysis, like using the past data, stored data. There is nothing but static data. Static data is nothing but already recorded. Non-real time data is nothing but static. It works on the static data to make reports and all. It's all like structured data in warehouses. So, for example, if you have to ask question like something happened, so what happened in the business? Show me the dashboard. Then, if you talk about reactive big data, so here also, since it is reactive, we are still working on the past data. So big data is what you are using huge data, working on huge data, using models and all to working on much larger data and all. That is nothing but reactive big data. In simple one, use much larger diverse data sets, but still on stored data. Though you are using large data, but not real time, it's stored data. Example, offline analysis of all last month, clickstream logs and all. Proactive analytics and proactive big data is without big data, and this is with big data. Both are analytics itself, but one is with big data, one is and another is without big data. Without big data is nothing but predictive models on smaller and relational data. Traditional database, you have to talk simply traditional database. This is the latest like big data analytics, where you work on real time data streams, etc. Combines huge and fast data with advanced models. It's all like working on big data. You just have to talk about BDU over here. If once you finish this, you can simply refer the notes for much understanding, and even in textbook it's very small, so you don't have to worry that do you understand this or not. Just remembering these words and explaining your work is more enough. Key big data terminologies. You have in-memory analytics, in the sense storing the data in RAM instead of hard drives. Then in database processing, nothing but using the logic, analytics logic inside the database engine. SIMP versus MPP. What is that? Symmetric multiprocessor versus massively parallel processors. Here nothing but you have to talk about multiple CPUs. They share the symmetric. They share the same memory and OS. Okay, so since it is symmetric, both same. So symmetry means what? Same, right? You have to remember like that. Same memory, same OS, tightly coupled. Good for medium processor. But massively parallel processing, each model has its own CPU, its own memory, and say own operating system. Okay, so nodes work on different parts of the job in parallel and talk via messages. So in parallel, multiple processors, they have their own CPU and OS and all, but for one user. So parallel versus distributed system. Parallel, right? Parallel in the sense what? You have multiple processors working together for a single task. So that means only one user. So you cannot see multi-user performance over here. Versus distributed. Distributed is nothing but it has completely separate systems, separate memory, separate OS, and different users. So you have multiple users, one memory. For example, using the lab, your college lab, so that is distributed systems. Okay, so shared nothing architecture. So shared nothing is it shares nothing, like zero, no sharing at all. Very lonely guy. It's each node has its own CPU, own memory, own OS, and this nothing is shared over here. Pros in the sense, what is it? It is good for fault tolerance. One node failing doesn't kill others, and easy horizontal scalability. Cap theorem, consistency, availability, and last is partition tolerance. So cap theorem we have also studied in DBMS if you have in your previous semesters. Cap theorem, it's nothing but in any distributed system you can strongly have only these three major things: consistency, availability, and partitions. But you cannot have all three of them together. You'll have always only two of them paired. Either consistency and okay, let us say what is consistency, nothing but every time you read something, it has to be latest data. Whatever you're trying to read is latest data. Availability, no matter what, even if the node fails, it has to give some reply, something it has to show you. It has to show something. What is this last one? Partition tolerance is nothing but system keeps working despite network splits. So you cannot have all three together. You can see, you have to write about CA, CP, and AP. Okay, you can have either two at the same time and then complete. So this completes our chapter 3. I will firstly, cover the remaining topics under chapter 4.1 and 4.2, and then that completes our first module.